humans explore about the cosmos, we are slowly uncovering knowledge that our forefathers did not know. As we build more space explorers, robots and telescopes, we are starting to realize that there are more planets similar to or just like us in the universe. They orbit around their host stars in what we call the Goldilocks zone, and they have similar rocky compositions like our beloved Earth. But are there humans like ourselves living on these planets? That's a question not even the most advanced scientist can answer. You see, the universe is massive and we are light years away from other systems. Within our own Milky Way system, astronomers estimate there are about 100,000 million stars in the Milky Way alone. Outside that, there are also millions upon millions of other galaxies. So if there are so many stars within our own galaxy, then there must be other planets just like us. The ingredients in the recipe for earthly life, water, elements associated with life, available sources of energy, appear to be almost everywhere we've looked. So, why then can't we find evidence of life apart from life here on Earth? Why we have yet to find another Earth with life, intelligent or not? Observing signs of possible microbial life in exoplanet atmospheres is currently just out of reach. No convincing evidence of advanced technology, radio signals or other means of communication, or the telltale sign of, perhaps, massive extraterrestrial engineering projects has yet crossed our formidable arrays of telescopes in space or on the ground. Are we really alone? When Harvard professor Avila Webb discovered possible signs of extraterrestrial activity, it caused a scandal in the research community. Professor Webb unequivocally stated that it would be arrogant to think that we are alone in the universe. In 1992, the first planets outside our solar system were discovered via a pulsar 2,300 light-years away that signaled at slightly odd intervals, indicating there were two worlds orbiting it. Following this discovery, millions of other planets were discovered. According to Overby Dennis, if life is so easy, someone from somewhere must have come calling by now. The Fermi Paradox is the conflict between the lack of clear, obvious evidence for extraterrestrial life and various high estimates for their existence. On October 19, 2017, astronomers made the first ever detection of an interstellar object passing through our solar system. Designated 11-2017 U1 Oumuamua, this object confounded astronomers who could not determine if it was an interstellar comet or an asteroid. After 4 years and many theories, the astronomical community appeared to land on an explanation that satisfied all the observations. But did this really satisfy our curiosity? Siraj from Explain to Universe Today via email states, the attraction of the nitrogen iceberg hypothesis is primarily in explaining Oumuamua's non-gravitational acceleration. Just like for a hypothetical hydrogen iceberg, a nitrogen iceberg's outgushing activity would not have been detectable in the measurements that were taken of Oumuamua by the Spitzer Space Telescope, which simply limited the abundance of carbon-based molecules around Oumuamua. As a result, the sublimation of material could conceivably power the object's observed non-gravitational acceleration. We know that mass is key when it comes to identifying Earth-like worlds. Some research suggests that objects just 1.6 times the size of Earth are more likely to be gaseous, making them less similar to our planet. I think it's a spectrum, said astrophysicist Moya McTeer, who completed her doctoral thesis in exoplanet habitability. There are points you can pass to make a planet more Earth-like, and I'd say mass or radius are some of the benchmarks. Being in the habitable zone of a star is also important. The world should be able to host water and have an atmosphere not as thin as Mars, but not a puffy, Neptune-like atmosphere. Unpacking what it truly means to be Earth-like evokes a host of scientific and philosophical questions. Although defining that term is pretty complicated, there are some worlds that appear to fit the description, or at the very least, parts of it. Some of these Earth-like worlds are, for example, Kepler 186f. The planet, dubbed Kepler 186f, is located about 500 light-years from Earth in the constellation Cygnus. Kepler 186f is a noteworthy location in the search for life. McTeer Haas previous studies the eccentricity of Kepler 186f's orbit in order to learn about the planet's potential habitability, even if it spends part of its year in the habitable zone. If Kepler 186f's orbit is too eccentric, it would have large temperature swings, McTeer said. But I found in my research that Kepler 186f's eccentricity is pretty close to zero. It doesn't experience big temperature swings, and so it's more likely to be habitable. Kepler 452b. NASA considers exoplanet Kepler 452b and its star to be the closest analog to our planet and Sun so far. Though it's 60% larger than Earth in diameter, Kepler 452b is thought to be rocky and within the habitable zone of a G-type star similar to ours. TRAPPIST-1 located about 40 light-years away. The TRAPPIST-1 system has quickly and rightfully garnered a lot of interest. Not only do all 7 planets in the system appear to be Earth-size and rocky, 3 of them are located in the habitable zone of their star. While liquid water could theoretically pool out TRAPPIST-1e, F and G, the other planets are probably too close or far from their sun to be in this Goldilocks zone. While TRAPPIST-1 hosts some interesting prospects, its planets are not Earth's long-lost twins. Some research based on computer modeling suggests even the habitable TRAPPIST-1 planets may have developed like Venus, making them too hot to host water. TRAPPIST-1e may be the only planet in the system still hospitable to life, but without more data, it's impossible to confirm. There is something deeply humbling in looking to far-flung worlds for something shared with our own. It takes a lot of precise circumstances for a planet like ours to exist. The idea that this exactness could repeat itself doesn't subtract from how special Earth is. It amplifies the possibility that life can thrive somewhere else. It's an honor to be this common. Please like, share and subscribe for more videos.